event. I'm honored to be here as part of your incredible lineup of speakers. I am not here so much as the chairman and CEO of Jaspersoft as I am a student of this amazing transformational discipline known as big data. And so in that regard, I'm as interested in being in the audience and listening to this great list of speakers as you are. You know, there's nothing I like to do better at 8:30 in the morning than intersect economics with information technology. How about you? So that's what you were thinking about first thing this morning? You know, this side of the room just said, I'm going to get more coffee. By the way, I chose to use this morning because the trade-off is, I don't know what's worse. Is it worse to look like Britney Spears or not be able to move around? I'm choosing to be able to move around by using this, but I hope it doesn't get in the way. I am going to intersect economics with information technology, in this case, the rise of big data. Anybody here have studied economics or is studying economics? A few people? Okay, just a few. So I can take some pretty good license. When no one raises their hands, I know I can pretty much say whatever I want. But in this audience, I knew that was not going to be very likely. The course of what I'd like to talk to you about today follows this pattern up here. The new factors of production and the rise of big data is based on an article I wrote for Forbes about a year and a half ago. And it came to me through a story that I'm going to share with you in a moment. But the course of my presentation basically looks at classical economic theory, contrasting those original factors of production with what I'm posturing as the new factors of production that create the most amount of economic value. Now, clearly at the center of this is information. So big data has come along at a time that is in no way suspicious. So I'm going to spend some time with you also talking about big data myths, misconceptions, misunderstandings around big data. And then we'll move over and talk about just how transformational it will be, this thing that we're referring to as big data. I'll conclude with some actual applications that are being used today, some of which are remarkable and all around the globe. And then lastly, I'm going to end and conclude with value, because ultimately it is about delivering new value using this data in some clever and unique way. Sound like a plan? Okay, you might want to get some coffee because we're going to jump into the economics portion right now. Let's talk about the new factors of production and the rise of big data. Now, my story begins with me, the protagonist, standing in line at a small Mexican eatery at the corner of 4th Street and Bryant in San Francisco. It was lunchtime and I had my $7 and I was determined to get a burrito. I was standing in line with a large number of people, and of course this small family-owned restaurant had free Wi-Fi. So at the time, this was about 2 years ago, at the time I was experimenting a little bit with Foursquare at the time. You know, everybody familiar with Foursquare? Location-specific check-in for establishments. It's reward-based. I was determined to be the mayor of Chavos at some point, so I dutifully checked in. And I knew I had some time between my checking in and being in this queue and ultimately being able to order my burrito. And what did my thoughts turn to at that time? Economics and big data. This is where you pity me, right? I'm standing there just hoping to get a burrito. And so from that anecdote, which I'm going to come back to at the very end of my presentation, I was thinking, and the realization to me was, wow, is maybe this family-owned small Mexican eatery on this indiscreet corner in San Francisco, maybe this is immune to these otherwise immutable forces of information. Maybe they don't have to compete like so many other enterprises must today. Maybe this is a corner, a last bastion of immunity. And that's what I was thinking about as I was standing in line. I'm going to let you know how that turned out at the very end of my presentation. In the meantime, let's turn our attention to the new factors of production. Now, classical economic theory holds that there are 3 primary factors of production. A factor of production in this sense is defined as something that facilitates the construction or the process of a good or service, but does not become part of the end good or service like a raw material would. It's an enabler. And for millennia, land, labor, and capital have been described as the primary factors of production, meaning that the correlation between owning lots of land, being able to employ lots of people, and putting lots of capital to work is the fastest way to create lots of economic value. And surely for hundreds and hundreds of years, through agrarian and industrial economic times, these factors of production held true. Today, in fact, somewhere probably 25 years ago, a substantial shift began to occur. Not in every industry. I don't want to make this sound like it's completely uniform, because certainly certain industries today still must rely on the utilization of land and labor in order to create economic output, no doubt. What I'm posturing, though, is that two of these factors, land and labor, have substantially changed, been replaced in most industries and most sectors. Although capital, as the third factor of production, remains equally important to its history. And while today's discussion is about technology, I won't go into capital. I'll simply point out that our methods for raising and deploying capital, especially over the last 40 years, have changed dramatically, no doubt. But this is a conversation about data, so if you don't mind, I'll set that aside, and if you have questions about it, maybe at the end or later in the day, I will be around. So let's talk about the new factors of production. What's replaced land and labor? Answer: time and information. And in this new equation that I'm submitting, I'll admit that time and information are not equal. Time is the new metric on which we're all measured, competing on the basis of speed. Putting more information to work to allow us to compete on the basis of speed is the change agent. It defines in most ways those who create greater economic value and those who will struggle to do so. I have lots of fun examples around competing on the basis of speed. And so I want to start with the element of time. No doubt that the computer industry, the information industry itself, has been an amazing example of competing on the basis of speed. Replacing it, disrupting itself annually. Moore's law, the ability for microprocessors to create much greater performance and throughput at much lower prices every 18 months. Memory speeds and costs, storage arrays and costs, everything about computing, even delivery through the cloud is all about taking away substantial portions of the cost model to make it more affordable for many, many more people. So surely the information industry has set a blistering schedule for all other industries to follow. And at the same time, the information industry has provided the enabling tools for all other industries to compete on the basis of speed. This is why I've been especially proud to have spent 28 years in information technology. And in my last 20 years in Silicon Valley, I've seen the most amazing amount of disruption, data becoming the center of the literal universe. We're back to a little bit of the crazy times in Silicon Valley, I will admit that. Funding models, valuations, and so on, especially around this big data equation, are astronomical, but for reasons that are reasonable. My favorite example, though, on competing on the basis of speed does not come from the information industry. It comes from automotive industry. This is a Prius. How many of you drive a Prius? If this were Northern California, like half the hands would go up. In the Bay Area, we have Porsches and Priuses, so that means we have money and guilt. Yeah. This is a picture of a third-generation Prius. I couldn't find a good one of a first-generation Prius, which is really what my story's about. Damn that Google Images. That said, the Prius provides a great example, just a great example of competing on the basis of speed. Toyota is well known for putting more information to work than most any other manufacturer. It's said that the first generation Prius in about 2007 was produced in 15 months. From the point at which the project was greenlighted to the day at which the first unit rolled off the production line was a 15-month span. Now, if you've ever spent any time in the automotive industry, you would know just how remarkable that is, especially for a first-generation vehicle. Admittedly, Toyota had been experimenting with hybrid drive systems for a number of years prior to that. But this was the first production implementation of a full hybrid drive system inside of an automobile. And before you write this off as a heavy goods manufacturing example that doesn't apply necessarily to information systems, let me point out that the Prius has more software, lines of code of software than any of us have probably written in our careers. It's basically a computer on wheels. An amazing example of combining disciplines at a manufacturing level and competing on the basis of speed. It's an incredible discipline at Toyota. There's a great Google Tech Talk video on this. If you Google competing on the basis of speed and Toyota, you're likely to find this. But let's get to information, because it's the real change agent. It enables us to compete on this basis of speed. And there's no doubt that you've seen, just as I have, all of the industry reports that describe just how much data is in the digital universe. We're almost getting tired of it, right? Here's one report that says in the next 18 to 24 months, the digital universe is going to be almost 8 exabytes. How much is an exabyte? 1 exabyte is all words ever spoken, to give you some idea of how unfathomable this amount of data is. Another research project at the University of Southern California estimates the digital universe to be 300 exabytes. Well, what's all that? That's amazingly different disparity. And the answer is everyone's trying with their own models to estimate just how big this universe is becoming. And rather than try to pin it down, let's just admit it's big. Right? We're drowning in data. We're bathed in bits. It's all coming at us at a velocity that's hard to imagine, especially even 5 to 10 years ago. So what do? Well, Paulo mentioned the 3 V's that have been constantly posited as one way to start to get your hands around big data and this onslaught of information. I like to give you 4 V's, because when you come and hear me talk, you get 33% more V's for your money. That's the way I like to look at it. I add veracity in there, truthfulness, because ultimately data quality is actually really important. And even though it's easy to set it aside in many big data solutions for valid reasons, and I'm going to talk to some of that in a minute, it's still ultimately going to be important. But volume, variety, and velocity are incredibly important determinants, and they help you actually frame a solution to a big data opportunity. I'm going to explain that more in just a little bit. We haven't been that good, though, as a society, and organizations and enterprise. We haven't been that good at putting information to work in general. I have some data that says we can do a lot better, and I have some data with me today that says, we're doing okay. So let's take a look at all of it, and you be the judge. This is some pretty recent data from Gartner, who tracks this stuff pretty closely. Their CIO agenda survey last year, published this year, says that on average, enterprises realize only 43% of technology's potential in the enterprise. Seems like we could do a lot better than that, especially with all of this new data coming at us. Gartner goes on to say that the CIO needs a new agenda for dealing with this digital business. So how do we set out to create this new agenda? How do we do that? Well, the first thing we need to do is truly understand the facts behind what this information onslaught is all about. How do we parse it? How do we deal with it in a way that's actually productive? And I'd like to do one more thing, one more story for you. As I conclude here on talking about time and information being the new factors of production, so critical. Why is it so important for us to get our handle on this? Time and information. It's because you can have no more of the former, and it's because you have an unlimited amount of the latter. That we all have a newfound responsibility to put it to work to create more value in society, in organizations, and enterprises. It's literally there for us. It's up to us to what we do with it. First step is understanding, though. The first step is understanding. Have you heard it referred to as a big data problem? Have you heard that term? Yeah, I've heard it referred to that, and it puzzles me, because I think it's only a problem if your competitor puts the information to work more cleverly than you do. That's a problem. Otherwise, I'd prefer to refer to it as an opportunity. But that opportunity can be masked or made to seem more difficult because of a lot of misconceptions, misunderstandings. And so I wrote this article for Mashable. This was a fun one because I was literally sitting in another restaurant in San Francisco over lunch, and I was with some colleagues, and I jotted down the misconceptions I had heard about big data, and I showed it to a bunch of people, literally the napkin. I said, what do you think about these? And uniformly people said, yeah, that's what I hear too. And I thought, maybe there's an article in this. And so I wrote this article, Mashable publishes it, and it becomes, would you believe it or not, that this becomes the most retweeted, socially shared article on Mashable. It's a shock to me, and it tells you that there really is there's pining for information about this. So let's dig into these misconceptions. The first misconception about big data is it's all about massive data volume. That's it, that's the only descriptor. Not true, myth busted. It's also about variety and velocity. In fact, volume alone is probably the poorest indicator of a big data opportunity. Experts would say we have maybe petabytes of data to put to work before you have a real big data situation. All right, but it's a moving target. So rather than focus on a moving descriptor, let's talk about variety and velocity, the two elements that are probably very much better at defining the scope and a solution in a big data opportunity. Variety is amazing. That's probably the most important part of big data. Today, we aren't just analyzing structured relational data as we have for decades. We're analyzing all sorts of data that previously might not have even been considered data. Weblogs, video footage with comments, photographs, geoposition information, on and on. So it's an amazing amount of variety that we're dealing with. Velocity is a tough one because it's so misunderstood. I'm going to give you my definition of velocity, and I'm hoping it will help you. Velocity is the time span that you have to put the data to work before it becomes stale and loses value. That could be sub-second, or it could be days. There's no right or wrong answer to velocity. It's a matter of matching up the right latency with the right business problem or business situation. But it's the time that you have to put it to work before it becomes stale. That's probably maybe one of my favorite definitions for the working of velocity. So massive data volume, that's not big data necessarily. How about big data is all about unstructured data? That's what it's about. Also not true. This is better termed multi-structured data types. It's true that big data includes unstructured data, text strings and so on, that literally have no structure. That's true, but it also includes elements of data now that have some structure called semi-structured data and some data that's very well structured. Form-based data, which is becoming very popular in document-oriented databases, has quite good structure. You can do a lot with form-based data. Geopositioning information, delimited at least, so calling it purely unstructured data and thinking about it is insufficient. So I would prefer the term multi-structured, and that would be more accurate. Also because big data types commonly have more than one type of data in a given data set, not just one type of structure, but multi-types of structure. I think what we can all agree on is these multi-structured data types are poorly suited to the old technologies that we've been using to analyze and store relational structured data. So it's not just about unstructured data. Myth number 3, big data is all about Hadoop. Everybody's heard of Hadoop, of course? Yes? Yeah. No, big data is not just about Hadoop. Although Hadoop is probably the term and the software framework most closely aligned with big data. It's just one of 3 classes of big data technologies and solutions. And it was born in the inner realm of Google, known as MapReduce, and now available in open source Apache license under Hadoop brand. Hadoop is a software framework. It has a variety of components. It's designed to solve for very broad scale distributed data processing problems. That's what it was originally designed for, and it does this very well. Many of the components of Hadoop are actually replaceable, which leads me to my second category of big data solutions, which is NoSQL. NoSQL data stores rely on different schema technologies, a variety of them, to store and use data, and it's the second class. I'm going to talk more about that in a moment. And the third, often overlooked, is massively parallel processing databases, analytic data stores. Vertica, Netezza, Greenplum, these are great examples of scale-out, highly vertically oriented columnar, usually, data stores. All of these are valid solutions and data stores, not just Hadoop, but there are several ways to do this. Matching the right solution with a business problem, once again, is always important. So big data is not just about Hadoop. Number 4, big data is all about social media and sentiment analysis. That's what it's for. Not true. As I've already described, there's a wide variety of big data types, structures, and associative processing techniques. True that it's confusing because most of these big data techniques have come from the world's largest social media companies. Google, Yahoo, eBay, Facebook. They have to solve for some enormous data processing problems. The idea of processing semi-structured or multi-structured data for sentiment analysis, relatively new, and just one part of what could be considered a big data opportunity. Right. So social media and sentiment analysis, a good use case for big data, but not the only one. The last one is that NoSQL equals NoSQL. And that is not true as well. NoSQL stands for not only SQL, not only SQL. Originally coined as an acronym. It means that these processing and data storage technologies have the ability to store data in a format that is potentially retrievable using classic SQL-like structures. But it also means that they have a usually API-based mechanism that provides a lower latency approach to retrieving and processing the data. So in most of these cases, the most popular data stores in the NoSQL category offer both options. And that's going to become a bigger and bigger requirement, make no mistake. The big three are Mongo, Cassandra, and Couch by volume today, but we're seeing Redis, React, some of the Memcache, some of the graph-oriented databases becoming very popular as well. All of these structures fall under the category of NoSQL. So big data is not just about, big data is not NoSQL, is NoSQL. Okay. So my hope is to have brought everybody together with a little bit better understanding about what big data is and what it isn't. In so doing, we busted 5 what I've seen to be very common myths. Let's turn our attention, though, to the transformative effects of big data. It's important for us to know that putting it to work in productive ways is the only real goal. It's going to have the ability to process more amounts of information than we've ever known before is going to have an amazing effect across all of society. I like to think of it as truly transformational. And so what I'm going to do is talk now a little bit about letting us think beyond today. But the way to do that best, if you're a futurist on Sand Hill Road, the way you do that is you think about the past, where we are today, and then you project that nicely and neatly into the future. So I'm going to do that with big data as the backdrop across 4 major categories. And my goal here is to help us understand just how transformative it is and how it will leave no lives untouched ultimately. I plan then to take this into some applications that are in action to give you some more vivid images of how big data is transforming our world. Information architecture, the organization in which we dwell, the social aspects of big data, especially privacy and legal, and then the cost model for making this technology truly pervasive. Let's start with information and architecture. Yesterday, we were used to working with structured relational data. We got quite good at it. We were mostly volume constrained because of the costs and the difficulty of skills available to put this data to work. The latency was relatively high if you compare it to today's standards, meaning we were pretty good at dealing with the data in, say, hours, which was really fine for lots of applications. And our architecture was inherently scale up, which means that if you wanted more processing power, you had to buy a bigger server with greater CPU capacity, with more memory and more directly attached storage. It was a unified scale up architecture. And you were fundamentally limited by the constraints of that scale up architecture and to how much processing you could get done. Today, we're dealing with almost in equal volumes because of the effect of NoSQL, relational and NoSQL data, very common application sets. We're schema constrained today. If you're a data analyst or a database administrator, this is heresy to you, right? I mean, today these NoSQL data stores are schemaless, or at least the schema is defined later, after you've captured most of the data, which is a brilliant idea in most ways, but antithetical to everything we've done in the past. So today we're schema constrained, right? Today we still think about the entity diagrams and the data sets and how they're going to be structured as the data is being captured. And that's a limitation. We're good at dealing with a wider variety of latency types. I would call it medium latency, down into the minutes, up to days. So we're better and more agile, but still not completely agile. And we are employing more scale up alongside scale out techniques. Scale out would be virtualization, the ability to grow servers sideways as you need more processing power. Virtualized everything, virtualized memory, virtualized storage, software-defined everything. We're getting much better at this today, and it's having a profound impact on the architectures of our computing. Tomorrow, though, the world is multi-structured. There's no going back. The world will deal with more data. We will deal with more data types in this world than we even can think of today. There'll be no end to the surprises. In fact, we'll be idea constrained. What will we do with the data? The notion of the data having value, much like a physicist would assign value to energy, we'll think of it in terms of kinetic value, that the data is being put into work, into action, and latent value, where it's stored for some future use that you can't yet envision, but your ideas for the future will pull you there. One of my favorite examples is the Litro camera. The Litro camera is an amazing new product that allows for the photographer to capture 11 million rays of light when it's pointing at a certain scene. What's the benefit of this? You can decide later, within those 11 million rays of light, what you want to focus on and what angle is best for you, because it's capturing all the information about that scene so that you can later decide what you want to do with it. A perfect analogy to this future of big data. And of course, it's going to be low latency or any latency you want, scale out, shared nothing, virtual cloud bursting. This will be the common way we do it. We'll think it was silly when we built all these data centers that weren't shared. Next category is organization, skills, people, sort of the soft aspect of this, the skills required. In organizations, we've been putting data to work mostly reactively in the past. We got really good at it. I would call it responsive, but it wasn't everything it could be because it was mostly designed by experts. A handful of people in an organization that really knew. They always had the title analyst, something analyst. Valuable people, but you needed to go to them to get your reports. They were the holders of the data. And as a consequence of that, very few individuals in an organization would actually interact with and use data regularly. It was a very individualized matter in that sense, about producing a new report for somebody that needed to analyze something. Today, however, we're becoming quite proactive. We're very good at sensing and knowing and proactively putting things in place based upon patterns and data. We're dealing with a lot more data today, and part of the benefit is that more and more knowledge workers are both skilled at and have access to the right analytic tools. So Gartner and IDC and others would estimate today that somewhere around 20% of knowledge workers in the course of their day actually use analytic tools. Not bad, but we can do a lot better than that. In the future, it's about predictability. It's about avoidance and the ability to sense and understand what's going to happen so you can act ahead of that. The data and the patterns will be there. It's about how cleverly we apply it. Everyone, at some point in their day, all knowledge workers will have access to and use some form of data in an analytic equation to make a better data-driven decision. We're far from that today. We have 80% gap to close across the knowledge worker universe. And inherently, this will be a community-driven activity. And by community, I mean fabric-like communities that exist both inside of your proper organization as well as other nearby organizations, perhaps in a community of practice or community of interest. And this sharing of data and information will become much more fluid. Socially, we have a lot ahead as well. The past and society of privacy, protection, and the legal aspects of information and data. In yesterday, it was quite private, right? Things were locked down physically and secured. They were out of our control, handled by somebody else. In fact, even today, large organizations still have sort of that chief security officer who's responsible for all elements of securing data and intellectual property and so on. The focus is on securing those records. Today, we've moved into a different environment. In some ways, it's hard to admit this because of social media, but we have to be honest with ourselves. It's semi-private and public. A lot of the things that we create, a lot of the data that we're creating through the click stream of our day is public. It's somewhat generational. If you're a millennial, you're comfortable with this. You've grown up with it. If you're my age, you're struggling with it. And what does it all mean? What information do you want to put into the ethosphere? It's a good and open question. And security, the focus is on is encrypting and detecting and of trying to determine attacks. And so it's definitely a reactive world that we're living in right now, and we're at an awkward teenage time of figuring out the real rules around social aspects of data. So here's what I posit. In the future, this will be one of the most transformed elements of society. I submit that in the future, you reclaim your privacy individually. You reclaim it. And in fact, it could become a currency for you. If you think about your preferences and your likes and all the things that you do in the course of a day, that has commercial value to a lot of organizations, especially if you are in a favored position among social networks. In the future, you'll be able to reclaim all of those rights through software agents that allow you to be very precise about with whom you share and at what fee, so that it becomes a commercially driven engine. This will transform the way we think of secrecy, privacy, and protection, and there'll be a lot of legal and social implications that come from it, essentially controlled by you, and it's focused on you being in the center of avoiding and preventing the use of information that you don't want. The last element is cost. This is pretty straightforward. A lot, a little less, a lot less. Yesterday, today, tomorrow. We spent millions of dollars yesterday creating analytic systems of relevance. Today, we're spending, say, hundreds of thousands. I'm proud to say that open source technology has been at the forefront of driving the cost model down. I've been involved with open source software for 15 years. Jaspersoft is a commercial open source software company. Our goal is to make this software usable by everyone, both for cost reasons as well as simplicity. In the future, it'll be the combination, though, of the cloud, which is being driven demonstrably by open source software, and big data that come together. That is an intersection of the most potent value you can possibly imagine. And I want to share a quick story of a meeting I had 2 weeks ago in my office in San Francisco with the CIO of a very large financial services firm based in New York. This CIO was especially proud at that moment as we were talking about his information architecture. He was proud of the fact that he was creating a robust, private internal cloud. He was properly proud. And he was also proud that they had been using Hadoop for 2 years in their own cluster to store data for which, at the moment, he has no idea what he's going to do with. And I thought this was fantastic. In my mind, this was an amazing advancement. In so many ways, the old financial services firms in New York are the last to be able to see some of this new vision. And so I had this incredible ray of hope as this CIO from a 150-year-old bank was describing this private cloud and Hadoop cluster. And it didn't even matter that he didn't know what he was going to do with it, because he got it. And so we spent the next hour talking about what my company could do to help him get value from that data. It was a great conversation. In total, 7 billion people on the planet, big data will touch all of them and transform their lives in ways that today we can only begin to connect the dots to. So let's talk about putting some big data apps in action. Some of these examples are phenomenal. I'll admit briefly say that some of these are Jaspersoft customers, some of them are not. I wanted to be egalitarian. I wanted to bring you some of the best examples that I've run into in industry. And it's from all over the globe. There's no corner that is doing better at big data, in my opinion. I'll admit that the United States, by volume, is probably doing more with big data than other parts of the world, but some of the cleverest apps are still in Australia and the continent in Europe and on and on. And so let's take our first stop to Cambridge, England. Jagex Game Studios, the largest online game manufacturer in the UK and one of the biggest in the world. How many of you have played RuneScape? Come on, be honest. RuneScape, massively multiplayer online game, the most popular in the world for free. That's the flagship title for Jagex Game Studios. They have 40 other titles, but that's the one that they're best known for. This about 2 years ago, they sought to replace an antiquated analytics system with a much, much richer infrastructure. The gaming environment is amazing. I've spent a lot of time with different game companies. The analytics inside of games is as sophisticated as the games themselves. The best gaming companies use analytics during the course of a gaming day to alter the environment of the game to create a bigger commerce experience. Jagex, along this path, uses a variety of techniques. Hadoop, they have a 160 petabyte Hadoop cluster, of which it's only 40% utilized. They ingest many, many terabytes of data into Hadoop from the gaming environment. Their goal is to establish cohort analysis, subscribership, and churn, and understand what parts of the game are not being received as well. Their latency, their velocity is 24 hours. For them, that was plenty sufficient. That means every morning the executives at Jagex gather around a table. They're looking at a series of dashboards and reports on what they refer to as game telemetry, and they make adjustments all during that day to better create a gaming environment that yields a successful commercial model. Now, they find all of this to be, the data that they create to be so differentially important that when I asked them for a sample of their dashboard, this is what they gave me. And it's not your eyesight. They blurred They blurred out all the categories that would have made this dashboard interesting because they don't want me out there showing what they consider to be a genuine advantage in their industry and sector. We've had a lot of fun working with JAGX. Let's come back to the United States, a company called Boundary. Wouldn't it be fair if the hardworking IT operations teams actually got to participate in big data? That's what Boundary does. Boundary is an on-demand SaaS-based model that sucks in terabytes of data for every enterprise IT operations team, creating at once a single consistent view for monitoring, measurement, management of everything in the operations stack, from routers to applications, alerts, performance to tuning, on and on. A customized experience all delivered online and on demand. An amazing array of gauges, graphs, and analytics that helps an IT operations team punch above their weight. I was thrilled to see this because that's a group that's commonly underlooked or commonly sold to at very high prices. Next, Clockwork Solutions. Enterprise asset management, the Internet of Things. Sensors plus software. It's all good. If you run a capital-intensive business with assets that are a big part of your economic equation, fleets of cars or planes or trains, shop floor equipment, on and on and on, anything that requires maintenance, repair, operations, and management, and depreciates on some schedule, around which you can better analyze and monitor. This is a wonderful example of new types of data that 10 years ago we never would have thought of data. The heat coming off of a brake pad correlated with the miles per gallon of that truck. Who would have thought to have been able to correlate that 10 years ago? Today, it's genuine data. Clockwork brings it all together into a series of dashboards and reports. One customer alone, Clockwork saved nearly $500 million in maintenance and repair costs from better managing their assets. In total, the first 6 months of this company's life, they saved their customers more than $2 billion in total. An amazing ROI. The Internet of Things is going to have a profound impact. How many of you have a FICO score? Everybody familiar with the credit service firm and the analytics behind it? Everybody's got a FICO score that's in the Western world. There are about 2 billion of us that have a FICO score. How many data points would you guess is the FICO score based on? That might be a loaded question in this audience because you might know quite a lot about FICO. Anybody have a guess? 5. 5 data points determine your FICO score. That algorithm was created in an era of small data. It had to be. So whatever your FICO score is, it's based on a very few set of traits that you represent in this world. Hamburg, Germany, a 50-person startup called Credit Tech. They are bringing credit scoring to the other 5 billion people in this world for whom the FICO model doesn't apply. They're revolutionizing the microloan industry. Their average loan after approval is €150. Transformational for some individuals in certain parts of the globe. How do you score somebody who lives in a hut? For whom the 5 scores, the 5 elements of FICO have no application. And the answer is you suck in 8,000 data points about that person's socialness, e-commerce purchases, online persona, and you use it as a predictive algorithm to determine their worthiness of paying back that $150 loan. They deliver a credit reference check in less than a few seconds. They've already processed millions of these. The default rate is less than 13%, and they're bringing a revolution to a part of the world that needs to be touched by big data. Market psych. This is truly big data in every sense of the word. Behavioral finance researchers taking the social net and turning it into predictiveness for financial markets. They are gauging consumer sentiment on a nationwide level, country by country. If you haven't been to the Market Psych website, I urge you to go there. It's fascinating, especially in the United States in the last few weeks, because they measure things like public anger, government unrest, consumer purchases and sentiment. And they use all that to make predictive guesses on the movement of major market indices, commodities, currencies. You can imagine how much money could be made when these guys get it right. They are ingesting an enormous amount of data, and they make it simple, mostly because they've been spending the last 12 years both in research and practice doing this. A really amazing example I urge you to go check out. Ultimately, big data is about value. It is about turning those potentially revolutionary solutions into greater economic output, greater societal benefit. And so I'm going to try to give you a few elements of value, maybe some proof positive that we're on the right track, and maybe some encouragement for even more progress in the course of the next several years. My first stop on the big data value equation is with James Tobin, a 20th century economist known for much research and work in both the private and public sectors. One of the things that he designed that's still used today in econometrics and finance is his quotient, Tobin's Q, which seeks to relate an organization, an enterprise's tangible asset value, corporate asset value, the size and wealth of its property, plant, and equipment, with its market value. The market value, of course, is the share price on a publicly traded exchange, which includes tangible assets plus intangible assets, which are mostly intellectual property, information rights. And Tobin's Q can be plotted for the average organization, as it's done here, over the last several decades. And you'll see a really important crossover point somewhere in the 90s that showed that an organization's differential use of information and intellectual property, on average, became the most important component, surpassing tangible asset value. Before that, the green line being above the blue line means that a company's physical property, plant, and equipment was worth more than the company on the publicly traded exchange. And so this is part of the reason during the 60s, 70s, and 80s you saw breakup artists coming in and tearing companies apart, selling them off for their tangible assets. There was plenty of incentive. Along came information and more clever use of intellectual property, and this changed. When Facebook went public a couple of years ago, the value of their tangible assets was about $6 billion, which is quite amazing, frankly, for a software company. I can't figure out how they have $6 billion of tangible assets, and I've been building a bunch of software companies, but they did. Their market value, $106 billion. The difference, the value ascribed to their intellectual property and their information use. Eventually, the financial world, the GAAP accounting world, will get wise to this and will have to figure out how to use and document and account for information rights and information use on balance sheets. That's going to be a tough one, a tough road to cross because of the legal implications and the consistency implications that GAAP requires. But it will happen. If you plot Tobin's Q over an even longer period of time for all companies on any US exchange, you see this upward curve proving that a very, very broad set of organizations have become much more clever at putting information to work and using intellectual property to their advantage. This gives me optimism and hope that we're on the right path and that we'll be putting information to work for the good of organizational value and society. More data, this time from academic research. This was really exciting to me when it came out in late 2011. Some of you are probably familiar with it. It's research from MIT and the University of Pennsylvania researchers that collaborated on an expansive study to determine how much value is created in organizations, the organizations that really make data-driven decisions. Are they really creating more value within the organization? And this research team went to great lengths to normalize out other variables in the IT equation and elsewhere in these organizations that could have had an effect on organizational output, so as to isolate for data-driven decision-making. And they did. First time ever that research shows the value of using data. The outcome was that organizations that put more information to work in more data-driven ways create 6% better output and productivity, and greater asset utilization, return on equity, and overall market value. Finally, data that shows us the value of data. It was really quite a breakthrough. Lastly, under value, I'm going to point to this book. How many have seen this book? It's becoming very popular. A handful. Urge you to read it. It's one of the better ones on big data because it focuses on the business side of the equation as much or more as it does on the technology. Lots of great examples. I'm going to give you a quick summary right here because the entire book is about creating value from big data, and it'll expand your thinking about the possibilities. Firstly, where we are today with big data allows us to use all of the data, not just a subset of it. Random sampling for research purposes and for data gathering has been the mainstay for many decades. It began in the census, the original census gathering process in the 1800s. And in fact, we perfected random sampling over the years quite well, and it leads to today to a plus or minus 3% against the total data set. Not bad. In a small data world, that's not bad. What if you could use all the data? Why wouldn't you? Why wouldn't you consider outliers to be just as important as mainstream respondents? What other patterns might you see by using all of the data? And the answers keep coming every time we see another application of big data. Our ability to put all the data to work is an incredibly distinguishing trait. No longer having to rely on random samples. The biggest problem with a random sample is once you want to click into a subset of the data, you largely cannot because there's not enough data behind it in order to support any good decisions because now you're into a smaller data set. Using all the data gives us literally an infinite set of possibilities for making decisions on a single, complete data set. Reduced exactitude. In a small data world, you have to be very exact, and you have to find and establish causality, the cause or the root cause of some movement in the data. Those are very important in a small data world. In a big data world, you don't have to be so precise. There's lots of interesting information out there that's not as precise. I sit on the board of a Dutch-based company that creates a fuzzy logic-based matching engine to allow you to find very inexact answers to a search. Incredibly relevant when you're searching biometric information, when you're searching even resumes. Might be good enough to be close, not exact. Turns out that our fingerprints aren't that unique. 1 in every few million people will actually have the same fingerprints with no relationship. So if, as a biometric marker, you're trying to establish identity based upon a single data point, you're going to be off on occasion. Well, what about if you could correlate a retina scan with a fingerprint? Well, you've just substantially improved your accuracy. Could you do that in a small data world? No way. Could you do that in sub-seconds in a small data world? Can't happen. So the less need for exactitude is an incredibly powerful agent in big data. Database administrators are going to have to get used to messy data. I'm sorry to ruin your world, but the world is schemaless, at least to start. And so messy data that comes in different fractions and portions is actually okay, and we can learn a lot from it. There are many examples in this book about messy data being the key to unlocking big value. Causality yields to correlation. In a small data world, we have to have causality because the data set requires it. We need to find and establish that causal link. In a big data world, correlations are just as important. When it was culling through many petabytes of purchase information, Walmart found an important correlation between the incidence of natural catastrophes and the purchase of batteries and Pop-Tarts. Now, you could search in the data all you want, and I pretty much guarantee you're not going to find a causal link between a natural catastrophe and the need to consume a Pop-Tart. But that doesn't matter to Walmart, because now, when a big storm is coming to an area, and you're at the checkout counter of a Walmart, what are you going to find? Batteries and Pop-Tarts. Correlation is more important than causality when you can deal with the entire data set. Datafication, an amazing phase as well. I've already talked a lot about datafication because this is about taking elements of data that in the past we never would have thought of as data and we're putting it to work. Sensor-based data, geoposition information, correlating all these things to create new solutions, maybe even integrating it with structured data that we've been used to working with to create a new answer for a new problem. Amazingly powerful, and the datafication of the world is what will lead to more and more big data applications. Of course, all of this brings social, legal, and moral implications that the book spends a reasonable amount of time on. I won't here, but I'll simply urge you to go read it if you have time or interest. I found it to be a really good one among many. My one small commercial break for Jaspersoft, I had to do it. I am the CEO of Jaspersoft, and so our job in this equation is to allow for the broad and pervasive use of analytics. We're a commercial open source software company. We're most commonly embedded inside of other software. That's what we're the leader of, embedded reporting and analytics. 16 million downloads of our software, 350,000 registered community members that grows by 5,000 per month. We are a living, breathing big data equation, I will admit. We're about bringing self-service BI and embeddable BI in an affordable way to allow organizations of any size to design any report or dashboard or analytic view using any data source that they need without any restraints, and then deliver it inside of any application or business process or onto any device, because our software is incredibly modern, designed to be used in the cloud as easily as it's used on premises. It understands this multi-structured, schemaless world. And so we've done very well, and I'm proud to be the leader of it. And the organization that we built, I'm hoping that will touch your life in some way. As I leave you here with ways to keep in touch with me or Jaspersoft, I want to bring us back to where I began, which is in line in the small Mexican eatery in the corner of 4th Street in Bryant in San Francisco, where I was determined to use my lunchtime money. Before I could get to the front of the queue and place my order, after I had signed into Foursquare, an important thing happened on my mobile phone. I received a location-specific ad from Foursquare encouraging me to walk a mile to save $1 on my lunchtime burrito at a competitor to this family-owned restaurant. Now, I didn't do that on that day. As cheap as I am, I considered it, but walking a mile to save $1 wasn't going to work for me on that day. Instead, what it brought together for me in great clarity is the fact that no organization is immune to the need to compete on the basis of time and information. And that my hope for that last bastion of family-owned restaurants was not to be. And so if I can leave you with anything, it is that we will all be affected by this. It is a great opportunity. And I hope that each of you can find your own path to competing more fully on the basis of time and information. Thank you very much.